In dealing with complex numbers, it's important to note that it all begins here, where you have the square root of -1. Square root of -1, we say, is equal to I, right? So let's talk about complex numbers. I remember as a child learning mathematics, one of the topics I was looking forward to is what do you do when you have a square root of -4? And I thought there might be something special, which it is special, don't get me wrong, but maybe I was looking for something more than what I found out that the answer would be. In this case, the answer is 2I. Well, how did we get that? Let's go here and write square root of 4 times square root of -1. We can do that because if you have the square root of a times b, it's equal to the square root of a times the square root of b. That is completely allowed. So if you have a situation like that, you can do the same thing like I did here. We basically have, in this case, this becomes a 2, and then we're left with figuring out what to do with this. Well, in mathematics, that is called I. So the answer is 2I. What I want to do in this video briefly is just go over the pattern with I, right? What happens when you have I squared and I cubed and so on. But please, if you want to learn this topic in more detail, do not hesitate to reach out. But this is what you would need for most standardized tests, just knowing how this works in the number of i's you might be given. And we could talk about the conjugate too of an imaginary number. So if we have I is the square root of -1, right? So let's scroll down here, or actually let's go to the next page. So I is the square root of -1. I squared would be the square root of -1 times the square root of -1, which is -1. Because if you multiply something, the square root of a radical times, again, you have the square root of a times the square root of a, you just get a without, this is called a radicand without the square root anymore. So I squared is -1. I was square root of -1. I cubed would be the same thing as saying I squared times I. We know what I squared is, it's -1. We know what I is the square root of -1. Therefore, I cubed would be equal to -I, or negative square root of -1. Do you see? So sometimes we just put that as -I. So that's I cubed. It's a very interesting one. I to the 4th is equal to I squared times I squared, right? That's another way of writing it. So I squared times I squared, which would simply be -1 times -1, which is 1, positive. Because a negative times a negative is a positive. So think about it this way. I is, over here, square root of -1. I squared is the square root of -1 times the square root of -1, which is -1 without the square root anymore. I cubed is -I, or negative square root of -1, and I to the 4th is actually +1. So we know what I to the 4th is, and we know what I squared are. That's two good landmarkers. But let's look at a problem. If somebody says, what is I to the 17th? What we do is, we know that I to the 5th, by the way, is the same thing as I to the 4th times I to the 1st, which would be 1, right? I to the 4th is 1. I to the 1st would be square root of -1. So I to the 17th, what you do is try and put I to something that is a multiple of 4. So multiple of 4. Why is that important? Because anything that is a multiple of 4, like I to the 16th, that's 1. So that just gets rid of the 16 i's right there. The only thing left would be a 1 because you've used up the 16, right? So 16 plus 1 is 17. So I to the 16th is 1. I to the 1 is square root of -1, right? That's the answer to I to the 17th. It's square root of -1, or you could just say I. So let's look at another example. If somebody says, what is I to the 48th? Well, 48 is a multiple of 4. That means technically it's the same thing as I to the 4 times I to the 4, right? 12 times. Do you see? And what happens in this case? It would just be 1 times 1 times 1 times 1, 12 times. So the idea is that you have a multiple of 4, right? Let's look at another one, I to the 27th. You look at 27 and you ask, what is the nearest multiple of 4 to 27? You say 24. So I to the 24 times I to the 3. Now remember the rules of exponents. X to the m times x to the n is equal to x to the m plus n. Do you see? So that rule is what I'm doing over here, backwards. I'm just showing that when I have a power, I can split it into 2 separate powers. And if this one is a multiple of 4, anything that is I to the 4 or I to the 4n, let's call it that, a multiple of 4, will always equal 1. Then you just deal with what's left over. In this case, I to the third. I to the third, remember from our pattern, we had I was square root of negative 1, I squared was negative 1, I to the third was negative I, or negative square root of negative 1, and I to the fourth was 1. So if it's I to the third, then that just becomes negative I. So the answer to this, I to the 27th, is negative I. Now, here's the thing. It doesn't matter how big the number is that they give you. They can ask you what is I to the 5,000. All you need to do is ask yourself, what is the closest multiple of 4? Right? And in this case, of course, we know that it's actually a multiple of 4. So the answer is 1, I to the 5,000. Or I to the 4,000, the answer is 1. If it's a multiple of 4, then you just find the nearest multiple of 4, write it out, right? What is the multiple there? And then write the leftovers of what's left of the power. That is what will then determine. It's either going to be I to the first, I to the second, or I to the third. And that will go back to our pattern that we see here. Because I to the fifth goes back here, I to the sixth, I to the seventh, I to the eighth, I to the ninth, I to the 10th, I to the 11th, I to the 12th. It's going to keep repeating over and over again. Let me know if you have any questions. Otherwise, have a great day. And please remember to keep track of what concepts you need us to go over and review when we have math discussion.